Um, this is the end of the long day. I was told to be high level and interesting. I know how to do high level. So let's see if this works, for example. So they asked me how long I wanted to speak to. The options were 30 minutes or 45 minutes. I couldn't imagine that you would want to sit here for 45 minutes. So we're doing it for 30 minutes, and then I got tempted to put too much stuff there, and then I condensed it. So let's see how well we do and how far we get. There are 4 things I want to get to, really 3 for sure, and 4 we get there. I want to speak about, everybody's speaking about AI today. I want to put it in a little historical context. I want to speak a little bit about the limitations of AI today and where I think some of the breakthroughs could take place. I want to speak about, so you know what AI is, artificial intelligence, you know what ML is, machine learning. 30 years ago, you would know what KR is, that is knowledge representation. That was AI 30 years ago. Today, nobody cares, and part of my story is I think we should care, in particular if we want to build beautiful software. And I'll give an example through one of the companies I was involved with. And then if we have time, I'll zoom out and speak a little about long-term view of machines and people and the connection between, but let's see if we get that far. So first point is AI successes in historical context. And everybody's speaking about AI today, of course. It's not the first time. In what year was it? 1985. Triple AI, which is one of the main AI conferences, took place in Los Angeles. There were 5,000 people. You couldn't stick a pin in the room. Oversubscribed, lots of vendors, and so on. Then came the AI winter, as we called it. Even if you were doing AI, you couldn't admit it. And of course now, if you fix refrigerators, you're doing AI. Everybody's doing AI today. So it's natural to ask whether it's another hype cycle and we're going to face another trough like we did in the 80s. And I think the answer is no, and because it's different this time. AI in the 80s was first ran on much slower computers and, of course, no networking like we have today, but even more importantly, it was based on logic and knowledge representation, expert systems, and so on. And those simply didn't have the power to deliver results that were compelling, and then there was a backlash. Today, if you're doing AI, you're doing machine learning, you're doing statistics, and it's a very different ballgame. Machine is doing the heavy lifting and very real results. And so if you look beyond the hype, there's actually impact after a long period where really no progress was made. There's no argument with successes today. And these are just some examples which you know well, and there are many others. I'm sure you're involved in some of these also. So that's the first part of the story, is this trend. But the second part is to inject a little humility. With all the justified excitement about AI today, sometimes we're getting a little ahead of ourselves. People predicting machines eclipsing humans, making humans irrelevant in the workplace, and so on. And we're so far away from true intelligence. This is a reconstruction of a cartoon I saw when I was a kid. I don't remember where. I can't find it. The original cartoon shows you a kid looking at the stars through a telescope, but standing on a little stool to get closer to the stars. And that's how I think about AI today. The stars are true intelligence, and the stool is AI today. And I don't mean to say that AI is not successful. Like I said, hugely successful. But in context, very limited. And to illustrate it, take a very simple sentence. Mommy, Daddy, Nanny hit me at school, so I hit him back, but the teacher saw only me hitting them, and so she punished me, and it's not fair. Every kid can understand it, and if you at all work in NLP or a dialogue system or anything, you realize how far we are from having computers begin to understand sentences like this. Because what you need to understand the sentence, you need to understand things like the passage of time, the action, the actors and the action they take, what causes what leads to what, beliefs, what I believe and what I believe that you believe, or what I believe that you know or don't know, emotions, sense of fairness, justice, and where will those come from? And my claim is that it won't come from machine learning or statistics, at least not if you're not willing to wait 5,000 years. We have it in our minds, and it took evolution a long time to get it into our minds. And computers today have a much thinner input stream, and the chance that they'll reconstruct it faster is, I think, low. And if you want to think about it in technical terms, if you're doing machine learning, you need a feature space to learn from. And if you're doing statistics, you need an event space, and events need states, and to describe the states, again, you need features. And where do these features come from? Well, if you're trying to learn something about images, the features are handed to you on a platter. They're, a pixel representation of one kind or another. Or if you have some kind of time series, or anything that's very well, or a game board. All of those the features are quite obvious. But in most cases, the features are very complicated. Time, causation, action, beliefs. And so will those emerge? And now that Google's next brain project will give you not only cats, but also time and beliefs? I don't think so. And so what do we do about that? Which brings me to my third point. I'm going to finish ahead of time. You see, capturing those features is what knowledge representation was all about 30 years ago. Whole sections in conference devoting to representing time and causation and beliefs and the other things we spoke about. I wouldn't let my students in recent years, so I retired from Stanford 2 years ago, but I wouldn't let my students in the last probably 2 decades touch this stuff because they would never get a job, not in academia, not in industry. But I think that's a shame. The knowledge graphs we have at Google and Facebook and Microsoft and Baidu are a very, very limited way of capturing knowledge, and already hugely valuable. Imagine if we manage to get much more richer knowledge into the representation. And if we do, at a very high level, this is the sort of image I have with what it would take to really get us to true intelligence, at least qualitative leapfrog where we are today. Now, this is very high level, and I want to give a concrete sense for how KR can actually interact with software. And I'll give an example through a company that I was involved with, Timeful, and the connection to knowledge representation. So I have a colleague, really an old mentor of mine, a logician called Johan van Bentham from Holland, one of the best-known kind of logicians. And when I was a graduate student, he sort of helped me, and we've stayed in touch. And I wrote a paper in his honor in the Journal of Philosophical Logic about intention. What does it mean to intend to do something? Very much a philosophical paper with absolutely no useful thing in mind, just because it seemed interesting. Still does seem interesting to me. And I'll just give you a taste for it. This already makes it more practical than the paper actually was, but the image to have in mind is you have some system that's doing planning, and it has databases to help in its planning to kind of keep track of things. So the standard database is a database of beliefs. So here are the information I have that I believe is true, and I'll keep track of it, I'll record it. And now we have a new database, which is my intentions. Okay, I decided to come to David Intercontinental, I was in Haifa, so I had a plan to take the car and drive there, and so I'm going to write that intention in this database. And as I go through my reasoning and planning, those databases will reflect both my beliefs and my intentions. That's the general picture to have in mind, and the question is, so what does that have to do with logic? And briefly, what is a belief database? It's a set of logical sentences, like, I believe that my car is in good working order. That's a belief I have. intention database has to do with various things I plan to do, and I won't get into details here, but things like I intend to drive from this time to this time from Haifa to Tel Aviv, for example. That could be an intention. Importantly, actions are gated by conditions. I can't plan to be driving if I believe my car is in the garage. I mean, in the mechanics. And so those are conditions associated with intentions. And what's important is if these were just databases, you wrote things down, that wouldn't make for an interesting story. But what's interesting here, and this is, doesn't start with me, there's a long, long tradition of belief databases that do this, they maintain consistency. So it's a very smart database where you add things to, you remove things, and if at any point in time the database becomes inconsistent, it fixes it. And it has rules for how to regain consistency. And now the story is more complicated because not only the database needs to be, the belief need to be consistent, I can't believe that it'll be in Tel Aviv and in Haifa at the same time. And not only do the intentions need to be consistent, I can't intend to do contradictory things at the same time, but the intention and beliefs need to be consistent. If I believe that my car is broken, I can't intend to drive my car from Haifa to Tel Aviv. So that's the story, and the question is, okay, so what are those consistency conditions? And if you really want to, sort of know what this theory looked like, it sort of had these things. From experience, this won't work, right? I won't even try it. So I have the current state with my current belief state and my current intention state, and now I want to update those with a new finds a new formula that I just learned. For example, my car broke down, and perhaps another intention that I had in mind to take action A at time t. Either of those could be null. I mean, phi could be the tautology true, or it could be the null action, but the real work is when they're not. And now the question, what does the new B prime, I prime look like in light of these? What are the consistency conditions? How do you maintain them? So that was a paper I wrote in Journal of Philosophical Logic with absolutely no practical intention, no pun intended, doubly, in mind. So, and that I did that in 2008, I think. Eventually it was published 2009. Then I wanted to continue the research, and you need funding to do. So I went to my funder I think in the US Army, I think it was, and he said, great, I like the story, I like you, I want to fund you, but give me a practical justification so I can justify it to the funders. And I had various justifications, but then it occurred to me that my calendar has lots of intentions. And then it occurred to me that my calendar is really functionally almost the same as my grandfather's, which is mind-boggling if you think about technology has advanced and how our lives have changed, and yet you have these rectangles here and there, or these lines, and that's bizarre. So, so we started to think not only about the theory, but about this application in academia, and then at some point we started a company. And the idea was this, is that calendars capture certain kinds of intention, traditional calendars, namely meetings and events. This is a great example. I have this event in my calendar. That's a beautiful coordination device because, you and I know that at 4 o'clock I'll be here. But I have lots and lots of other intentions that don't look like that. Things like I want some me time, productive time, to be working alone. I want time for friends and family. I need to run an errand. I like to jog 3 times a week. I want to sleep. Just time to think. All of these compete for the same resource called time. And yet they don't have a voice in my calendar. And so what happens traditionally, especially in a knowledge work and corporate environment, that my calendar is hijacked by only those that have a voice, those meetings and the events. By the way, if you want to think by analogy with time, it's not only the time that this money, time, is spent on a particular kind of things, it's that other people are spending it for me. Most of the things in my calendars are events that other people put on it. That's not a good way to manage money or time. So what we said was, let's rethink of what the calendar is and give a voice to all those intentions, give them the flexibility that's required because, for example, If one of my intentions is to do laundry in the evening, it doesn't have to be at 7 p.m. And so if I use a traditional calendar, I'll need to put it at a particular time, but that's silly. Let me express the flexibility. It needs to be sometime this evening. I need to be at home, and that's it. And let's give the flexibility, and let's express, and let's now help you manage this most valuable resource you have in an intelligent way that improves your life. That was the idea. After a couple of years of research, it became a company with my then student, later my boss, Jacob Bank, and Dan Ariely, whom you all know. And I'm going to tie this back to knowledge presentation right now. Timeflow had three sort of principles or pillars that sustain it. One was the data model, the intention object. I'll get back to that in a moment. Then, once you had all these things vying for time, it's impossibly hard to do as a human. You needed to bring algorithms to help you juggle all these flexibility and the thing compete for time, so we did that. And then, since it's so hard to do, we have so ingrained bad time management habits, you want to engineer the environment to nudge people so they don't lapse into those bad habits. Those are three pillars, but what I want to focus on is the first pillar, because that's central to the story here. Those are intention objects. What's an intention? So our basic data model was the intention object. And the intention object was based on what we called the intention genome. Just like Pandora had the music genome, which took music and broke it down to a feature vector of 100 things that are quite subtle, leading to an understanding of music that's much more subtle than genres such as rock and pop and classical. We aimed for the same thing with intentions. We had a feature vector of several dozen features. Some of them have to do with time, like when do you want to take this to act on this intention? It can be within a time period, by a deadline. It can be things like times of day or days of the week, various temporal aspects. There are other aspects. Where do you need to be? Do you need to be at work? Can you be at home? Do you need to, or can you be at a car? Can there be other people around? What tools do you need? Do you need a phone? Do you need a laptop, and so on? So once we had this feature vector representation of intentions, we had what we call our intention genome. And of course, we didn't present the feature vector to the user, but now we could flexibly reassemble them into categories, familiar ones and novel ones. So for example, by the time it was sold in 2015, we had 4 packaged things we surfaced to the user. We had events, the familiar events. We had tasks, which usually live in a different application. They live in a task management system or on a piece of paper you write down. Here, they're intention objects, perfectly legitimate. We had something we called good habits, or simply habits, like jog 3 times a week. And towards the end, we added projects. These are long things you don't sort of do and done, a single seating we call those, but you chip away at until you're done, like work on this presentation. And then we surface them in the app. So for example, the top circle is team meeting, that's a standard event. The second circle is workout, that's a habit. I want to work out 3 times a week. And the system suggests this time. And the last thing is call mom, a task that appears there. And these are flexible. So for example, workout, the system suggested, but I could quickly say this is not a good time and dismiss it, and the system would find a different time for me. And by the way, through machine learning, very quickly home in on the times I like to work out, and so on. So that's what the app looked like. And now you can see that it kind of came with thinking rather generally about what an intention is. But intentions, this really logical work that I started with, wasn't only the motivation for doing a new kind of time management system and not only help define the data objects, but throughout the process, it kind of was a good guide to how to engineer certain features. And Maybe I'll just pick one example. Take the second one, no tasks news to someday. So every task management system who here uses some kind of task management app? Really? I just remember it? Anyway, the few that did raise your hand, you know that you write down tasks, and typically you say, when do you want to do it? It's today or tomorrow or next week or someday, right? Those are usually the usual categories. We didn't have someday. And it comes down to what is an intention. An intention is a commitment. If you want to think it logically, the most basic object is a commitment. I commit to you to do something, An intention is simply a commitment to myself. But it's still a commitment, not just something that has no force. Otherwise, it wouldn't be an intention. It would be just an idea. I actually intend to do it. It has some force. I could change it, unlike a commitment where there's the other side that needs to let me off the hook. Here I can let myself off the hook, but it's still a commitment to myself. But for a commitment to be real, it needs to have some kind of time scoping. And that, by the way, in my paper was really a reaction to a previous paper by Hector and Levesque called Intentions is Time Plus Commitment, where in many ways it's a seminal paper, but it was flawed. And one of the flaws, I argued, was that the basic object was, I commit to doing something or to achieving something. There was no time scope. And when you think of it, it makes no sense. When my kid says, yes, I'll clean up my room, that has zero power. I say, when? Today? Okay, now we're talking. It still won't happen, but at least there's something to talk about. So my argument was that the basic object should be a commitment with time scoping. And you can then start to relax it and say, not a particular time, but by a particular deadline, and so on, but it has to be time scoped. And that's what we had in the system. We never allow you to choose to someday. You always have to time scope it. That's an example of where really work that was not motivated by anything practical ended up informing what we did. The general message, and I really believe this, is that we all want to build beautiful software. But if it's not beautiful on the inside, and what I mean by that, if the abstractions aren't right, if the data model isn't right, you can camouflage it. You can have wonderful pixels and animations, but it's lipstick on a pig. You really want the internal to be beautiful, and now you can surface a beautiful product. And the argument is that the only technology I know to engineer, to give you disciplined, semantically meaningful, clean representation is knowledge representation, the way we used to practice it 30 years ago. So that was my third point, which actually miraculously leaves me time to speak about, if you thought this was high level, wait for what I'm speaking about now. So everybody's speaking about AI today, and the question is, where will it end? And you have these, on the one hand, optimistic views of machines doing all kind of wonderful things, and then you read Yuval Noah Harari and you want to cry because machines are going to make us obsolete. And so what do I think about it? I think we need to distinguish between the short term and the long term. And by short term, I mean sort of something on the order of 5 years, maybe 10 years, no more than that, but even less than that. And in the short term, is AI good or bad? Let's start with that. As a technology, technology's not good or bad, it's the way it's used, but typically technology has benefited mankind. In fact, with no exception. You can argue that Hiroshima wasn't the most shining moment for technology, but technology on the whole has benefited mankind. I have no doubt that's true for AI too. And AI is fairly powerful, so it'll probably benefit humanity greatly. But it doesn't mean that along the way there aren't hiccups. Industrial evolution benefited humanity, but created a lot of disruption in the workplace. And people are worried about this, and I think justifiably so. I think there's sometimes hyperbole here. I don't agree with all the concerns, but by and large there's concern. So if cars can drive themselves, by the way, I don't think they'll drive themselves as quickly as some people think. At least maybe trucks on the highway will, but no doubt drivers will lose jobs, and that's significant. There are many drivers in the world. So that's the legitimate concern. We have biases when we approve loans, for example, or in job interviews. As we outsource this function to machines, it's not only that people won't get to do those jobs, it's the fact that the biases may get amplified unintentionally. And you already see some examples of that. People worry about unethical fighting in the battlefield when robots are involved, and so on and so forth. So I think all of these are very legitimate concerns, and the people worry about that. The people, especially in the States, creating institutes to worry about it, and I think that's a good thing. And I think this is a dealable with problem set of issues, and so I'm not worried because we are thinking about those things. That's short term, 5 years, 10 years. But what about the long term? You know, machines are getting so good. Is there any role left for us? Is there any difference between us and machines? And so I usually, of course, all of these are longer conversations than the 5 minutes and 20 seconds I have left, but I always started with the question of, kind of these questions of, I asked people to think about whether computers could do any of those things that we typically view as uniquely human. They're representative, they're not the only ones I could ask. I asked whether people think computers could, in principle, like not today on your laptop, but in 500 years on a giant computer cluster, can computers be creative, have feelings, have free will, and so on? Just show of hands. Let's take free will. Let's assume you have to vote. You have to be awake. You have to vote. You have to vote either yes or no. You can't abstain, and you can't say, well, it depends what you mean by free will. You have to vote. Okay, that's the game. Just humor me. And you can't, I can't hear you anyway. Okay, ready? Who think computers can, in principle, have free will? Raise your hand. Okay? Who thinks, in principle, by the way, it should be the rest of you, that computers cannot have free will? Raise your hand. Okay. I'd say it's kind of like 95-5 or something like that. So I have a long story about that, but not in 4 minutes and 3 seconds. So what do I think about it? Short story is, I think the answer is probably to all of these is yes. And why will take more than 3 minutes, 47 seconds. I think I want to remember the boy on with the telescope on the stool. We're very, very far from that. And I also don't think it's a bad thing. And here's the one thing I don't worry about. I don't worry about those doomsday scenarios where machines, robots, or other machines will rebel and replace us as the human species. And that's for 2 reasons. First of all, we think today of computers as... Computers already now extend our cognitive skills, right? I mean, when I came here, I and Waze were one. But computers are sort of made of metal, and they're kind of separate from us. But that'll change. Brain-machine interfaces will happen. I don't know how quickly, but they'll happen. We'll connect wirelessly to giant data centers. And we'll have thousands of nanocomputers running in our bloodstream, fighting diseases and who knows what else. So the distinction of where we end and the computer begins will be much less clear. We, as a species, will evolve. So it's not us versus them. It's really us becoming something slightly different. And the other reason I'm actually excited about this direction of all those mental-sounding qualities being embodied in machines is because it forces us to start to think about ourselves. And I usually pick free will as an example. It's not an accident I asked you to vote on it, because the more you think about it, you say, well, what is free will and what does it mean for me to have it? And you say, okay, well, philosophers have fixed that, I'm sure. Let me read that. No, they haven't. And you look at psychologists and you look at religion. Kol tzafui v'rashut netuna. And my favorite quote is Isaac Bashevis Singer. In his Nobel Prize speech, he said, we have to believe in free will. We have no choice. And so you realize that nobody really knows what free will is, even though intuitively we feel it's such an integral part for what makes us humans. Well, now we have to think about it a little harder. And that's a good thing. We'll just understand ourselves better. And so that's why I think it's a good thing. If you want to know more about the two topics I discussed, here are ways to find out more, at least, of what I think about them. And I think I'm done. Thank you.